Hello, welcome back. In this segment, I will apply a bunch of natural deduction rules we have learned. We have already seen this text. If the train arrives late and there are no taxis at the station, then John is late for his meeting. John is not late for his meeting. The train did arrive late. Therefore, there were taxis at the station. Okay. We converted this into symbols as follows. We take P to be train arrives late, Q taxis at the station or late for his meeting. And from the description given in this paragraph, we were able to say P and not Q implies or, not or, and P, because we can see here train arrives late and there are no taxis implies John is late for his meeting, right? That's the reason for this implies. John is not late for his meeting is another premise. That means not or. The train did arrive late. That means P. Therefore, we are saying that there were taxis at the station. That's the conclusion we need to prove. Q is the conclusion we need to prove. We need to use and introduction, implies elimination, not elimination, not introduction, and double not elimination. These are the 5 things we are allowed to use. Okay, so let's go ahead and get started with the proof and convince ourselves our reasoning is correct, meaning there were taxis at the station. So how do we mathematically prove this? I have created the problem, right? This is the problem. P and not Q implies or, not or and P, and we need to convince Q is the correct answer at the end. First, we need to start with, say, not Q, okay, as an assumption. And what happens now? We can combine line number 3 and 4 by and introduction, right? At line number 3 and 4, okay. We have P and Q, but we also know P and Q implies or. That means this is or by the notion of eliminating implies by combining line number 5 with line number 1. Okay. And now we are in an interesting situation. We have or and we have not or. That means we can eliminate the not to come to a contradiction. So we have a contradiction, which is because of eliminating a not because of line number 2 and 6. I always want to check whether we are doing okay so far. Let's see. Yeah, there are no errors so far in our proof. We are on our way. So we reached a contradiction. So in that case, we started with some assumption. We reached a contradiction. That means our assumption must be wrong. So we can introduce a not to the assumption. So now we can claim that the assumption must be wrong. So it is not the case, right? It is not the case, not Q. So this is because we can introduce a not because of lines 4 through 7. Think about it, from 4, we have a wrong assumption. That's why we end up with a contradiction. We talked about one of the rules in the natural deduction rules, that if you start somewhere and you end up with a contradiction, your original assumption must be wrong. So that's the reason why we put a not in the front. Okay, so it's called not introduction. Okay, all right. So let's check the proof to make sure, yeah, we are on track. And now we can easily eliminate double knots using double knot elimination rule that we learned earlier. Okay, are we okay? There were sites too many. Oh yeah, I have to say double knot elimination on line number 8. Yep, the proof is correct and we are done. Going back to the overall structure, right? These 3 are the premises. This is premise 1, premise 2, and premise 3. We want to prove Q, but we start with not Q. And we can combine P and not Q because of and introduction. That's allowed. But we do know that P and not Q implies or. That means we can eliminate the implication. So we get or. Now we take or and we combine it with not or to get a contradiction. That means we can eliminate the not. That is the not elimination rule we learned. We start with something. We end up with a contradiction. That means the something must be wrong. And not Q is 1. You can view not Q as one symbol. So we are putting a not in front of that. And now we can do a double not elimination on this to get Q, which is exactly what we need to prove. If you go back to the original problem, we need to convince ourselves the conclusion is Q. Right, that's all. Thank you very much for your attention.